Yeah, go.
This is our bridge project. I'm Matt Markowski. I'm Billy Manicoco. Alright, we chose Warren Truss, much like a bunch of other people. And as you know, it was made by James Warren in 1848. And we chose it because it is very simple and it uses equilateral triangles. And it's designed to equally use tension and compression and not diagonal forces as we, so, yeah. That's the bridge in the wild. Yes, courtesy of Google Images. This is our West Point. We put it in a West Point. It worked pretty well. I mean, we could figure out which members were compressed and which members were tension.
It was also really cheap, and it was like the best for that like size and stuff. Because if you made it bigger or smaller, it was great. So it was like that was like exactly what we wanted.
Alright, this is one of our first sketches. It shows our dimensions. 48. It's not inches and centimeters, but 48 centimeters by 6 centimeters, and normally, traditionally, a Warren Truss is equilateral triangles, but we tested the isosceles triangles and we found that it works the same, if not better. And 215 grams for total weight at the end. And this is our bridge energy solids. This kind of shows the different tension and compression between different members in the whole truss itself. And construction. So construction went along pretty well. And we had four main components in our diagonal members, base members, corner joints, and middle joints. And I mean, it could have gone better. So this was our main thing that we kind of figured out in the end, but we'll talk about it more later. It's a chisel tip member and a no chisel tip member connecting at the center, and we'll talk about that later. But our base members, we also put quite a lot of time into because we had a lot of T-joints in our bridge, and we tested those, and it supports 12 to 13 pounds, just that T-joint. And so we pretty much took two members, took another member, stuck it inside, and then inserted the other one. Corner joints, we got this off as a document. We just used ones with the toothpicks and drill holes, and it was kind of painful, but it worked. In our middle joints, we chose to use chisel tip in the end, but the other one didn't have chisel tip and kind of didn't work.
Yeah, that was the side that broke.
Alright, this is our data. I'm kind of bad at making graphs, but so it kind of just leveled out. We saw it break, but there wasn't any true point where you could see in the graph where it broke. But we have pictures of that.
We have 32 pounds, by the way.
Yeah, 32.
Solid.
Okay, so the thing is, we had two different times because we were doing one way of doing these parts at the first side, and it was just we would just do the circle and just stick it on. But then on the other side, we cut a triangle in it, so it had more surface area and more stuff. The tension was been put on that one as well as the other one, so it's more equal. So that's the side that didn't break. Might also be because the side that broke was like uglier than the first one.
I think that our main problem was our craftsmanship. I think at the beginning of this project, our first side of our bridge really did not look good, and it really did not feel like it was properly made. And you can kind of tell why that was our main problem at the end. That was our broken joint that kind of put it in the dumpster, and it just doesn't look good.
So yeah, otherwise we did pretty good, but inside our joints could have been made better, and we kind of didn't really work as fast at the beginning as a lot of other kids. And another thing is that we had 215 grams, so we could have added a whole lot more. And also our middle parts were some of our thickest, and they were under the least pressure. So we probably could have made those thinner and just put a ton more weight on the parts that actually broke.
And I don't think it was more weight that we really put on, it was just stronger pretty much use a lot of glue to connect our members, and that kind of weighs them down and doesn't make them as strong, because weight doesn't imply strength. And so, yeah, we probably could have used equilateral triangles like a traditional warm truss, but it was experimentation.
Yeah.